Good afternoon, everyone. My name is Vivashni. My USN is U24 E01 IS084. So, aim and objectives are like to design and implement a lexical analyzer and the parser for the mini ATC language using automata theory concepts. And the objectives are to understand the lexical analysis and the parsing and implement token recognition using the regular expressions and design a DFA for identifiers and numbers and validate mini ATC program using CFG and to detect the syntax error in input of the programs. Next. So introduction for this automata theory is used for the compiler design, and compiler converts source code into machine code, and the lexical analyzer breaks input into tokens. Parser checks syntax using grammar rules, and mini it is a simple language used for compiler concepts. Next page. Slide. Okay, so mini it is language. So this is the basics one. Begin next statement list, and for the example begin, we have taken the x value as 10 and y value is equal to x, and next will be continued by Tasmia. So much that you agree with me. Your USN. Good afternoon, everyone. My name is Tayaba, and my USN is U24E01IS080. Next, coming to the DFA for identifier. Here, there is a rules that is it must start with the letter and can contain letters and the digits. Let's know the transition. First, there is a start state that is Q naught. When the letter is given to the Q naught, it will go to the accept state that is the Q1. Next, coming to the Q1, if there is a letter or digit, it will go to the self loop and accepted in a Q1 itself. Next, going to the DFA for number. Here there is a diagram in which it consists all the DFAs of letters, digits, symbols. There is a rules for the DFA for number. It must contain only digits, not any characters. Transition. Let's see the transition. That is Q naught is a start state. If we give digit to the Q naught, it will accept in a Q1. And if the Q1 has given by the digit, it will go to the self loop and accept itself. Now let's see the diagram. Next, here Q0 is a start state, and if we give the letters, it will accept in a Q1. And if there is another letter, it will go to the self loop, and rather than letter, it will go to the another. Means it will accept ID or keyword. Next, if we give the digits to the Q1, it will accept in the Q2, and it will go to the self loop itself. Next, if there another digit or any character, it accepts the number. Next, if there any symbols, it will accept in Q3, and if any the other symbols as well as that is Q4, and other than these, it will go to the dead state. If there any character rather than this, it will go to the dead state. And here is a DFA transition table in which there are the five states, that is Q0, Q1, Q2, Q3, and Q4. Q1 accepts the ID or the keyword. Q2 accepts the number, Q3 accepts the operators, and Q4 accepts the symbol. Next, this is all about the DFA for the number, letters, and the symbols and the characters. Next, coming to the output. This is our desired output of our program. Let me show the program to you. Okay, here is the program. I have linked these two programs in a main program, that is from Lexer import Lexer. This Lexer program is imported here, and the from parser module import parser. This program is imported here, and that is input enter mini. It will ask the input, that is enter mini ATC program. We have to write the input. Let me run. Okay, here we start with the begin, and we declare the variable and given value to the x in y is equals to x plus 10. Okay, now we are printing the x and okay, this is the output. The Lexer, it breaks down the larger symbols into shorter, and the parser module, it will differentiate the symbols. That is, here is the begin. It shows the begin. If there is a here, we use the int x. It shows the int x and ID. We are giving the x symbol, so it's shown the x. These are the symbols, and this program is syntactically correct. It will shown as you see here. Okay, this is the program, and it will run successfully. Okay, next, coming to the test cases. There is a valid test case and invalid test case. Valid test case means this program is completely correct and it runs successfully. This is the desired output of our program. We have given the desired input to it, and it will show the tokens which are used here, and this is the correct syntax. Next, this is an invalid syntax. I have given the wrong input here. That is begin int a is equals to 10, print a and end. Here it shows the errors here in which we have done something wrong. This is the invalid test case. Okay, next will be continued by Bhumika.
Afternoon, my name is Bhumika and my USN is U24E01 IS104. I'm going to explain about the context free programmer. So this is CFG, we can call it in the short form. This defines the syntax of a programming language. Use productions rule for this. And the main rule of this is program, it begins with uh, STMT list and ends with that. And its statement is like declaration. In declaration, we use it has an int ID. In assignment ID, and in print ID. So these are the expressions which usually supports this, and that is addition, subtractions, multiplication, and divisions. The next slide, please. Here is the parser design theory. Parser is the second phase of the compiler. It receives token from the Lixel analyzer, and it checks syntax using CFG, detects the syntax error. This usually detects the errors in the syntax which have been given. And how it works, it checks begin and end and validates statements and ensure correct syntax. Next slide, please. So after all of this, let me conclude about that. We have successfully implemented Lixel Analyzer and Parser. We have understood the DFA, regular expressions, and CFG, and we have also learned the compiler design basics, and we have also validated mini ATC program correctly. So this is all. Thank you.